before I give you some more examples, let me just make sure that you understand something first. So when you get given this here, and then you're asked to square it, what it means is you get this and then times by itself, times by itself. So basically, it means this: x to the power 3, y to the power 5, and then you've got to times by itself. So it means this: y to the power 5. Okay, what this means is x times x times x, and then times y times y times y times y times y, and then you've got it times x x x, and then times y y y y y. Well, let's just take these three over here. Okay, so that, well, basically what I'm trying to say is that this becomes x to the power of 6, and then y to the power, well, when you merge these together, it would be y to the power of 10. Okay, so when you have this here, it's basically this this times this, and then this thing here times this. Okay, so hang on, let me give you another example. If you have something like this, x squared or y to the power of 3, and then to the power of 7, well, that means, well, just get x x y, sorry, y times by itself 7 times. So you've got to times it with x x y times x x. Well, anyway, if you get all the x's together and merge them all together, there's some more over here. Basically, you would get this times this, so it would be this: x to the power of 14, y to the power of 21. So this, well, it would be this times this. And if you don't understand this, try it for yourself. If you have choose a small number like this, okay, to the power of 4. So you could see it like, well, you could visualize it like this: x times x. That's what x squared means, and then you've got to times it with y. Now you've got to times it with x x, y, and 4. Well, you've got to do it 4 times. So it would be x x, y times x x, y. Now let's move this these two x's over here, these two over here, these two over here. So basically it will look like this: x x, that's these two here, and then you've got to think about these two here. So that's x x again, and then think about this one here, that's x x, and then think about this one here, x x, and then look at all the y's now. You've got y, and then you've got to think about this y here. So y, y. So there's 3 more. Think about this one here, y, and then you got the last one, y. So this, well, this here you've got 2, 4, 6, 8. So it's really x to the power of 8, and here you've got 3 here, 3 here, 3 here, 3 here. So that's y to the power of 12. Okay, so it's in effect this times this, and then this times this. Okay, and even if you have something like hang on, x squared, y to the power of 3, z to the power of, let's say, 7, and then you power it to the 5. Well, that means, well, just get this times this, so it will be x to the power of 10, y to the power of 15, because you would get this times this here, and then get 5 times the 7 here, so it will be z to the power of 35. Okay, what that means is that if you have say 2 to the power of 3, and then 5 to the power of 6, and then you maybe power it to the 5. Well, what that means is, it means this: 2, well, get this times this, so that would be 2 to the power of 15, and then times 5 to the power of 30. Okay, This here represents your x. This here represents your y. But if you have something like this, x, if you have x to the power of 3, and then x to the power of 5, and then power this to the power of, let's say, 4. Well, because these two x's are the same, you can actually merge these two together. Last time it was x and y. These two are not the same, so you can't merge them together. Whereas these two, they're the same. So you could visualize it like this: x to the power of 8 here, because now you're timesing, so you plus the 2. It's only when you power it do you times. So this one here to the power of 4. Okay. So what I'm trying to say is you can merge these two because the x here and the x here are the same. You can merge. Whereas if you get given something like this, x to the power 3, y to the power 4, y to the power 5, and then to the power of 4, here the x is different from the y, so you can't merge the two. So it becomes this: x to the power of 12, y to the power of 20. Okay, but if you get given this x to the power 3, x to the power of 5, and then to the power of 4 here, well, because this and this, they're exactly the same, you could visualize as this: x to the power of 8 to the power of 4. So that would be x to the power of 32. Okay, it's like me giving you this. Hang on, 2 to the power of 5 and 2 to the power of 4, and then power to the 3. Let's say. What this means here is 2 times 2 times 2 times 2 times 2, and then you've got to times 2. It's going to be 2 times 2 times 2 times 2. My point is that because all these 2's, they're all the same, so you can actually merge them together. Okay, but if I give you something like 2 to the 3 and then 5 to the 4 here, well, here you've got 2 times 2 times 2, and then here you've got times 5 times 5 times 5 times 5. My point here is that up here all the 2's are the same, so you can merge them. Here you've got 5 and the 2 here. You can't merge them, so you just have to, when these two are the same, you can merge them. Just bear that in mind. But the important point of this video is these bits here. If you get given this, then it's just a matter of this times this, and then this times this. So in this case, it will be x to the power of 6, y to the power of 10. Okay. Yeah. So yeah, just get this times this, and then this times this. Okay.